Hi, darlings. We're going to do integration by parts today, which is one of the 2 remaining integration techniques you've got to do. This one's, if I just throw this at you and walk away, you're going to think I just invented something and it doesn't make any sense. So I just have to do a proof for you. So here's what we got. We've got 2 functions, f and g, and I'm going to multiply them. And then we're taking a derivative. So this all comes from, the root of this is product rule for differentiation, which we all know is first derivative of the second. I don't know what that is. That's a plus sign. Second plus second derivative of the first. That is a true statement. We all know it. It's product rule for derivatives. Great. Here's how I'm going to manipulate this and turn this into a by parts question. We're going to integrate both sides of this thing. That dx is not floating in space. It lives down there, but I can't squeeze it in. So we're integrating both sides of an equation. So on the left-hand side, look how nice. If I take the integral of a derivative, I just get f and g right back, f times g right back. These other 2 pieces, I'm going to separate and give them each their own, which we know we can do, fg prime integrated plus the integral of g f prime integrated. Okay, and then no magic happening. We're going to take this term and we're going to subtract it over to the other side. So what we end up with, and I'm going to write it backwards too. So we end up with the integral of fg prime is equal to fg minus the integral of gf prime. That was no magic. That was pure manipulation. And you don't, ta-da, we're done. This is integration by parts. It doesn't mean anything to you because you don't really know what's happening. But if I just threw this at you, you would think I was crazy. So let me show you the way you're going to see this, like the way you're going to end up saying it to me, is you've got to think of this as the integral of u dv. So you've got some function u and some derivative dv. I'm pulling these straight out of here. So f is that, and there's your derivative dv. It's g prime, so I'm calling it dv. The way you take this integral is uv minus the integral of v du. This is the way you will say it. This is the way anybody in the whole world will say it. It's not my thing. It's common knowledge. So what this means is when you have now an integral, and if I run through my options really fast, so like forget you know anything about by parts. If I run through my options, you don't know anything about by parts. If I run through my options, I'm not going to graph this and find area. It's not the back of a flashcard. There's nothing in there whose derivative is also in there, so it's not u sub. It is not a rational expression, period. So that entire second chunk of options are not available to me. This has to be a by parts problem. When you're running through your options, by parts is a last resort. You've got to check all your other options first. I promise it's a last resort. So here's what you need. You need to find in here something that we're going to call u and something that we're going to call dv. And I'm pulling that straight from here. It starts as the integral of u dv. This is different than u substitution. In u substitution, you picked a piece of it, like any little piece inside there, and then did your substitution. For by parts, you have to include the entire integrand, the whole thing. So this is your first one. You're just going to have to trust me. U is x, dv is sine of x dx. So notice that I included the whole thing. I can't pick and choose. So now I need the rest of my parts to integrate by parts. I need a du and I need v. So the way I move this direction, I'm setting this up the same way I've always set up my u subs, because when I move this direction, I'm going to differentiate. So the derivative of x is just dx, 1 dx. But when I move this direction, I integrate. So the integral of sine is negative cosine. And now it is a straight plug and chug. So I have this half of my equation that I'm plugging into. So this integral is uv. So u times v is negative x cosine x, uv, minus the integral of v du. Minus, but this is a negative, so I'm going to pull it and make it plus, the integral of cosine x dx. Now, hopefully, yes, I know that there's still an integral. I know we're not done. I hope you see that too. But hopefully this is now an integral you can take. It is. We know that one. It's a flashcard for us. So this is negative x cosine x. What do you differentiate that gives you cosine? Sine, and then plus c, and we're done. That's by parts. Let's do another one, and I can talk you through how I chose what I chose for what should be u and what should be dv. You're always pulling the same pieces. You need to pull a u, you need to find a u, and you need to find a dv. So remembering that the first thing you do is differentiate one and integrate the other, your u should be something that gets better. So if I can, I'm almost always going to let u be x because it gets better. Du is now dx. I don't have an x anymore. So something that will reduce in power in some way, which means dv has to be e to the x dx. E to the x doesn't get better. It stays exactly the same whether you're differentiating it or integrating it. So that would not be helpful to make as the u part. All right, plugging in, this is uv minus the integral of v du. And then hopefully you've created an integral you can take. Can you? Of course you can. We just did. So this plus c. All right, last one. What about this one? Okay. So I need to pick a u and I need to pick a dv. And I just said to you that you should let your u be an x or an x squared or something that will reduce in power as you take its derivative. So if I let u be x squared, great, du is 2x dx. It got better. It's not a squared anymore. It's just a linear. That's better. So dv has to be natural log of x. Here's the problem with what we just picked. I don't know how to integrate natural log of x. I mean, I do, you don't. You actually have to take the integral of natural log of x using by parts. So this, if you have to do by parts to set up a by parts, you probably made a bad choice. So let's do it the other way. U is natural log and dv is x squared. So, okay, I know. Look, we bounce back. I'm going to add 1, divide by the new. I made it worse. I did. I know that. But it'll be fine. Du is 1 over. And then if you've got that voodoo in your head, it's uv minus the integral of v du. This is the chunk that you're worried about. uv can be as ugly as it wants to be. It doesn't matter. You're done with it. But I have to go integrate v times du. So if I put these two things together, can I take their integral? Yeah, so I'm fine. So this is going to be, oh, so messy, x cubed over 3 times natural log uv minus the integral of v du. So when I multiply this v and this du together, I'm going to pull the 1/3 out, and I'm going to have the integral. Maybe I should write it down here. This is what it looks like. X cubed over 3 times 1 over x dx. But I'm going to clean it up. So I just pulled the 1/3 out, and x squared over x, or x cubed over x, is x squared. So sometimes it's not obvious that it's a quick integral, but a quick clean helps a lot. So final answer is x cubed over 3 natural log minus add 1, divide by the new, leaves me this, plus c. That is by parts. That is easily the hardest integration technique that you've got. And part of the challenge is choosing what should be u and what should be dv, and you're only going to get good at that with practice. So I have some practice for you. I wonder where it is. I'm sure you can find it. if you remember your login. Thanks, kids. Let me know if you need anything.